Hello and welcome to What's New in Aerospace. I'm Marty Kelsey, one of the hosts of STEM in 30, an Emmy-nominated TV show for middle school students, and we appreciate you joining us today for our talk all about Mars. Real soon, there's going to be a launch of the Mars 2020 rover heading back to the red planet, and we've got some awesome folks to talk about it today. We have Kobie Boykins, who's the chief engineer on the Europa Clipper mission at NASA's Jet Propulsion Laboratory, but before that, he worked on the Mars rover. We're also talking with Christina Hernández, who works on Mars Perseverance's Pixel instrument. And we're joined by Dr. Matthew Shindell, space history curator at the National Air and Space Museum. Thank you all for joining us today. All right, we've got a lot of folks tuning in, and we want to remind everybody to ask as many questions as you want. We've got some great experts. Try to stump them. Put your questions down in the comment section. We'll get to as many of them as we can. And also let us know where you're watching from. We would love to know where you're at, and we'll give you a few shout outs today. I want to get started today. Christina, tell us about the Mars 2020 rover and what's this mission all about?
Yeah, absolutely. So our launch window officially opens on July 30th. So we're imminently going to launch. So Mars Perseverance rover also used to be called Mars 2020. For the first time on one of our rovers, we are going to be actively seeking signs of ancient life on Mars. Additionally, because that wasn't enough, we're also going to be collecting rock and soil samples for a future sample return mission. We have tons of great science instruments. We have a heavy payload. We have 7 science instruments that are going to help us on our objectives. But not only that, we have this awesome Mars helicopter named Ingenuity that we're also taking with us. So it's action-packed. We'll be landing February 18th, 2021 on Jezero Crater. And what's really exciting about this landing site is that we're landing on an ancient delta. And so we think that's a great place to start looking for signs of ancient life.
Awesome. Well, we've got North Royalton, Ohio. We've got Italy joining us, Norwood, Ohio. We've got a lot of folks tuning in, so make sure you let us know where you're watching from and put those questions down in the comments section. Kobie, you've worked on a lot of Mars missions in the past. Tell us about some of the missions that you've worked on in your role.
So actually, starting at JPL, one of the first missions I actually got to work on in JPL as the Jet Propulsion Laboratory is the first Mars rover that we ever did, which was nicknamed Sojourner. And it was part of the Pathfinder mission. And I got to work on that as a student. So my roots in terms of the Mars rovers have gone back to the beginning, more or less. We landed July 4th of 1997, if you can imagine. So we've had presence on the surface of Mars from there, from that time. I was very lucky to be chosen as the mechanical engineer to develop the solar arrays for the Mars exploration rovers, both Spirit and Opportunity. So the things that make power for those rovers on the surface that were supposed to last 90 days, both did much better than that, 5 years and 15 years for Opportunity. So that was just the coolest thing ever. And then for the next rover after that, which is the Mars Science Laboratory on the surface now, still doing exploration, nicknamed Curiosity, I was promoted to my level of incompetence. They made me a manager. And as a manager, I managed the mechanisms and mobility groups. So that's everything that moves on the vehicle. So there's 31 actuators and a voice coil. There's the mobility system. There's the remote sensing mast. There's all of the things that in the arm and all the things. And so my hardware that I delivered for that, or helped work with a contractor, which was called Aeroflex at the time, now called Kobie, was to build all the actuators, all the things that move. And so we delivered all that hardware, and now that's been on the surface and working. And then for Perseverance, the newest rover, I was a manager of the mechanical section that did the instruments. So Christina and I have a connection because what was going on in the background with Pixel and Sherlock and some of the other instruments was all being built by the team that I managed to actually deliver that hardware to make sure it was okay to go to space. So from my roots there, it's been crazy. And I'll just give a little plug for the next thing is I got moved on to be the chief engineer of Europa Clipper. You can see the picture behind me. And so we're actually in the future right? As we talk about Mars and everything Mars, and I think that's really good as a focus, but NASA as a whole always is looking for what's next and the things that we can do. So we're going to go to one of the ice moons of Jupiter and do investigation with this unbelievable science suite of instruments. And it's in my opinion, it's the next thing, right? Looking as Christina brought up with what was happening early on in the Mars program, which I'll give a little background, which was, we were searching and following the water. Now we've started a program which is to seek signs of life. And so with this particular Perseverance, we're actually doing the next step of, we've now find out that there's water on the surface. Now, can we do the investigations with seek signs of life, which actually can culminate with human beings being on the surface?
Awesome. Well, we've got folks watching from Michigan, Iowa, Minnesota, Florida, Indianapolis, Arizona, Missouri, San Antonio, Texas, Punxsutawney, Pennsylvania tuning in, Pittsburgh, Raleigh. I also saw Las Vegas, Northern Ireland,
Nice.
and Fairfax, where I'm at right now. So thank you all for tuning in. Please put those questions down into the comments section. We want to know what you want to know about Mars. Matt, I want you to talk a little bit to us about why are these stories important for the National Air and Space Museum to tell?
Yeah, so I mean, the story of Mars exploration is important to us as a museum because it's such a large part of the history of the development of planetary science, especially the development of planetary geology and also astrobiology, the search for life in space, where Mars has been such an important target, as both Kobie and Christina have pointed out. So, we started exploring Mars in 1964 with robotic spacecraft, first flying by a few times with spacecraft that were able to send back images and some measurements from the atmosphere of Mars. Then with orbiters that were able to go into orbit and study the planet more long-term from orbit. And then finally in 1976, we landed the first successful landers on the surface of Mars. And those were able for the first time to give us some ground truth to what we'd been seeing from orbit and from those flybys and to really study the surface of Mars. Well, that was the Viking lander. We landed two of those in 1976, and you may be seeing a photo right now of Carl Sagan standing next to the Viking lander that we have in our collection, which was sort of a test version of the Viking lander. And, for the first time, that spacecraft was able to scoop up some of the Martian soil and put it into an instrument package that was able to analyze it, look for signs of life, understand its chemistry. And, that was a big first. Of course, then there was a 20-year gap in Mars exploration, partly because it didn't find signs of life in that particular mission. But then in the 1990s, as Kobie pointed out, NASA landed its Sojourner rover with the Pathfinder lander. And for the very first time, another big first, we were able to actually drive up to rocks that were laying on the surface of Mars and get to understand how those rocks came to be in that spot. And that was followed by a great history of successful landers, rovers. Up to this point, we had the Mars exploration rovers, which landed in 2004. And those were able to, as Kobie pointed out, follow that water, find out what the history of water has been on the planet Mars, and help to identify some of that history so that we could think about landing sites like the Jezero crater, which we're headed to now, where we think there was, a lake that stood for possibly millions of years, where those sediments might have been brought in by flowing water and then been deposited. And now with, the instrument packages, or the instrument package, that this new rover, Perseverance, is bringing to Mars, we're going to be able to drill down into those sediments and hopefully find out a little bit more, or a lot more, about that history of water and whether or not there was ever any life that got started in those wet environments. So, it's a great story. Mars is, aside from Earth, the most explored planet in our solar system. And this is another great landmark step in exploring that planet.
Awesome. Well, we've got folks tuning in from all over the place: Georgia, Portugal, West Virginia, Oklahoma, Chantilly, Virginia, and DC. Thank you all for watching. Put those questions down in the comments section, and we've got them rolling in here. And our friends in Northern Ireland would like to know about the landing site, and also, is that are we going to use that landing site for future crewed missions to Mars? Christina, you got any ideas on that one?
Yeah. Well, I can take a stab at the first part. So what's really amazing about Jezero, that's already been mentioned, right, is that we're landing on a paleo lake, so an ancient lake that was roughly the size of Lake Tahoe in California. And so you could imagine in Mars's ancient past, like 3.6 billion years ago, there being a lake filled with water. And now we're landing this rover that's equipped with instruments that can not only tell you about the geology, the weather, the environment, but also spectrometers that are going to be actually looking at the elements and organics that could be in these rocks and soil samples. And if we find anything promising, we have a sample caching system, which, Kobie can speak all to this, but the mechanics of that thing blows my mind. But it's like we can now collect the burden of proof for a future mission. And I can't really speak to the crewed mission part. Maybe somebody can answer that. But at least this landing site is so promising for being a habitable environment, which is the requirement if you're going to go and actively look for signs of ancient life.
Awesome. All right, we've got Robbie from Massachusetts, and he is excited because he gets to send his name along with the rover to Mars. Can you all talk a little bit about those programs, and are any of your names on the rover? Kobie, can you tell us about that?
Yeah, I mean, the Send Your Name to Mars program, which has been wildly, crazily used. When we first started, we were like, okay, how do we? And this goes back, right? I mean, this goes back even before Pathfinder, back to Carl Sagan and Gentry Lee, where, people in the clean room would come down with a little marker and sign their name on stuff. And it became one of these things, well, why are we just doing that from we're working on it? Why don't we expand that? And we got to the technology and ability to actually do that for a lot more. You think about the golden disc on Voyager, for those that aren't as crazy in the head. But Voyager had the golden disc with, voices and things like that. And so it's always sort of been part of the outreach to the country and the world to have people do this. And so starting with Pathfinder, moving on with Spirit and Opportunity, Curiosity, and now Perseverance, we have this online ability to put in your name, type in your name, it gets burned on a microchip. That microchip gets put in many layers and then gets actually glued or fastened onto the rover. I mean, I'll tell you, I put my name on every vehicle. Now, I was in the high bay, so I did write my name on a couple places, which, not everybody gets to do, but that's okay. But, my name is digitally on that disc. Like, what was it this year, Christina? Do you know how many millions of people actually sent in?
I can't even say, I mean, multi-millions. Yeah, it was a lot.
It was hundreds of millions of names that logged in and put their name on there. So it's a really cool thing to get your name going to Mars. And then you get the little thing that has a ticket of Mars. And I keep all that stuff. And my kids are all on
your
there
boarding
too,
pass.
So it's just really a cool thing, and it's a cool outreach thing that we get to do. And I think from the people that get to work on it, it's just as exciting for us to have a community of people that are involved and excited about exploration, sending their names with our vehicle to the surface.
I'd say from a historical standpoint, it's also great, thinking about this long history going back to Voyager and even maybe before that with the secret names that were snuck onto spacecraft, of how we've gone out into the solar system, not just to find out what's out there, but to send sort of bits of ourselves out there, whether that's recordings of music and sounds or images, or in this case, names. We've sent all kinds of things out into space with the spacecraft in sort of an attempt, I think, to connect in a human way with what we're doing out there where we can't yet get in our own sort of personal form, right?
Right.
And also, when we see the pictures that come back from the surface on the Mars 2020, Perseverance, and Curiosity in particular, there's a reason why the cameras are the height that they're at, right?
Yes, most definitely. I don't know, Christina, you want to take that one?
No, go for it.
So, I mean, the height of the cameras, I mean, starting with Pathfinder was, the IMP camera was this way, but not the rover camera because it was just too small. But once we got to Spirit and Opportunity, we actually put the cameras at 5'2". And the reason that we put them at 5'2" is because that is the average height of a human, at the time. And it feels like when you get the images, which we actually have two cameras that can take, can't remember the word at the moment, but where your eyes do this, take both images at the same time. and that we would feel like you're being on the surface of Mars. And so we've kept that throughout all of our vehicles. Even though our vehicle is significantly bigger, we want it to feel like a human being is standing there. And so as you look around and you see the environment that you're on, you actually get a sense of what it would be like to stand on Mars. And so it's sort of become the personification of our Mars rovers on the surface, so that people say, oh, I can tell how far that rock is away because I can actually feel like I'm standing there. And it actually helps with the engineering side as well.
All right, we've got Hunter, who's 9, wants to know, how long is it going to take to get to Mars? Christina, you mentioned it earlier.
Yeah, so it's going to take about 7 months. So on February 18th, 2021, you can mark your calendar, Hunter, and we'll be landing on Mars.
Awesome.
You know, I think one thing I would like to ask Christina, because I think some of our audience might not know, is, you know, why is the launch window so specific? What's so special about this time of this year?
That's a great question. And so in grad school, I did a lot of astrodynamics. So I am a junkie when it comes to planetary motion. But every 2 years, there's a moment in which the optimization of the distance between Earth and Mars is ideal. And so one of the things that when you're designing hardware to go into space, which is this extreme, nasty, hardcore environment for electronics, we want to minimize the amount of time it takes to get somewhere. And so every 2 years, we have a period of time. It's about a 3-week launch window for us, at least for Perseverance, where we can get to Mars in the shortest amount of time, which tends to be 6 to 7 months. And so that's why when that launch window opens, we got to be ready to go. Great question.
All right, we've got somebody commented that, speaking of names, they love the names of the space equipment, the programs, Curiosity, Opportunity, and they want to know if there's a list of names y'all keep in a drawer somewhere and pull out when it's time for naming something. I will say that later today we're going to be posting an interview on our website with Alex Mathers, who actually named the Mars rover. Student reporter Jaden Jefferson got a chance to talk with him, so that one will be out later today. But can you all talk about the importance of these names? And Matt, maybe you can take that one. Why is it so important that these have cool names and they're not just spacecraft XYZ?
Yeah, that's a great question. This year I actually volunteered to serve on the name selection committee, which that was not anything that I had to be selected for. You volunteered and you pretty much got the job because they received, thousands of name suggestions, and those had to be narrowed down and then narrowed down further until you had the final set of names that NASA got to choose from. And, I think it is important that they have names that have sort of the grandness and the ambition, the aspiration behind spaceflight sort of embedded in them. So, Spirit, Curiosity, Sojourner, even, which is, I think, so far the only U.S. spacecraft or Mars spacecraft that's had a human name. It was actually named after Sojourner Truth, but it also carried with it that idea of the Sojourner, the Wanderer, the Explorer. So, I think all of these names have kind of had that spirit embedded in them of what exploration is all about. But I also think it's great that usually the rovers end up with nicknames too, right? So Opportunity became Oppie, for example, and has a personality of its own. And Curiosity has its own Twitter feed where we can engage with Curiosity. I mean, there's a big sense in which these names help to engage with the rover as a public. I don't really know if the engineers end up giving them and keeping those nicknames and using them when they refer to them, but I know the public definitely does. And I'm making a push personally. I think a lot of people are going towards Percy when it comes to Perseverance. I'm pushing for Vera because Vera is right there in the name, and I think that one.
Oh, I love that.
If it catches on, everybody remember it started right here.
It started right here.
That's a good push.
All right, we have a question from a curious 6-year-old from the San Francisco Bay Area. I apologize if I mess up the name, Kurash. And he wants to know, how long is the battery life on the Mars rover, and is it solar powered, or how does it get power? Kobie?
So yes, so the this vehicle, just like Curiosity, so Perseverance, just like Curiosity, uses a multi-mission radiothermal generator, what we call an MMRTG. Now, what does that mean to you? Not much. What we do is we actually use the decay. It's a nuclear reactor. Think of it, in some ways it's like that. We use the heat given off by this device to make electricity. That electricity actually charges a battery. So you got it right, it's a battery. And then the solar missions, we use solar panels to charge a battery. Then we run the rover off the battery. The battery is very similar to the chemistry you have in your cell phone. And so from that perspective, it has a very long life. The reality is that we honestly don't exactly know how long the life is, because Opportunity lasted on the surface for 15 years. And that was awesome. But what we're trying to do is we try to manage the battery's temperature. So if the battery gets too cold or we discharge it too much, that will actually reduce the lifetime of the battery. And just like, the new electric cars that are out there, if you like the Tesla, or if you like the Kia, or if you like Hyundai, whichever one you like, whoever manufacturer you like, when they have those batteries, and they do have some life to them. We estimate that to be at 8 to 10 years of heavy use and discharge. And we manage that when we drive the rover and we actually do science. We try to manage how much of the battery we use so that we can make the vehicle have longevity. But one bad thing, one little lift of a interconnect, a wire that breaks, we could lose the rover. And that's sort of the risk and the exciting part for the engineers, because we have to try to find those things and then minimize the
troubleshoot.
Yeah.
All right. Well,
Christina, how much energy does something like Pixel take? I mean, you're using the battery. How much does your instrument take on the vehicle?
So that's what's really interesting about the instruments, right? Is that all the instruments have different energy modes, because we're very well aware of this problem, right? And for an instrument, you never want to be turned off on the surface of Mars, because we want to do science. And so an instrument like Pixel, right, takes maybe about 35 watts for a basic activity. But Pixel is also going to be doing these long duration 12-hour maps really close to the surface of Mars. And that's going to be a bit more energy intensive. But as rover planners, we also plan out, just like you were saying, Kobie, maybe one day it's a pixel-centric day, and I can't wait for that day. But other days, all the instruments got to play nice together and share the power. And so that's what's pretty interesting. They're pretty flexible.
And I'm sure there's never any arguments about who's going to get power when.
No, of course not.
All right, we've got a couple of questions coming in along the same lines. And this one I absolutely love. Somebody wants to know who actually drives the rover and how do they navigate without a map? And they said, I'm 65, but these youngsters have my curiosity. So awesome question. Thank you for watching. So how do we drive the rover? And I think there was a previous question about, is it autonomous?
Yeah, so that's, I can take a stab at it, and Kobie, feel free to jump in. So it's not just so when you drive a car, you go to training school. So we do have what we call RPs, or rover planners, and it's their job to command the rover in how to drive it. And they actually go to a rover driving school. So up in the Mars yard at JPL, we have a test bed version of our rover Curiosity, famously known as Maggie, the Mars Automated Giant Gizmo for Integrated Engineering, Maggie for short. And, they'll actually, put cones out there, and they have to say, okay, now we need to use the images on board, the rover flight software, context imagery, and we need to drive the rover, we speak in meters, but, you could do feet as well, right? Drive 5 meters and then turn right. And then move the mast, right? And so you're actually training leading up to operations how to drive the rover. And on board, what's really interesting, what I learned, is it is autonomous, right? And on Perseverance, we have even more upgraded flight software where the rover will autonomously be able to navigate and avoid targets that we deem as hazardous. And so not only is there a person in the loop, but the rover itself, Percy or Vera, depending on what side of the argument you're on, will be able to decide whether to adjust the wheels or not. So yeah, it's a very involved process. Do you have anything to add to that, Kobie?
Yeah, I would add one question, which is you can think of the Rover, and Marty, I don't know if you still have that picture, but way back when, I have actually tried to let people experience what it is to drive a Rover, and Marty actually got a chance to drive Scarecrow. And so from a high level, think of it as they have these toys that they can sell for kids, or the Lego makes the Mindstorm, and you program it in blocks. It's a blocked program type of thing. It's very similar to how we drive the Rover, except we have some higher order intelligence. And when I mean intelligence, I mean an ant, and that's being mean to the ant. So the Rover does understand that it can drive over certain rocks and can't drive over other rocks, but it is not an autonomous vehicle per se. It autonomously knows where not to brake itself. But I will tell a fun story really quickly, which is we were doing some really, really great driving. And this is fun for Matt too, because it probably ends up in the museum. But, Guinness Book of World Records is like the longest drive on Mars. And that was Spirit. And then the next day, Opportunity drove further. The longest drive on Mars, Opportunity. And we were, as people who do rover planning, and it was good for science too. We were trying to get somewhere. But the rover got stuck in functionally a snowdrift. It's a Mars drift of light dirt. And it drove 10 meters and buried itself. It didn't move, but it thought it was moving, right? And then when we got the pictures back, we were like, oh, this is not good. And so it's not super smart yet. Now, there's no GPS, so you can't actually get ground truth if you're moving. And just like your question from our young at heart, just like us, is that we don't have exact maps. We do have some imagery from Mars Odyssey and Mars Odyssey, Mars Express, and MRO, Mars Reconnaissance, that we can see the vehicle on the surface. Not perfectly, but we can see it. And we sort of know where we want to go. And so we'll plan with both imagery from orbit and from the surface where we want the vehicle to go. And that's a high level science plan. And then the rover planners and the people who are controlling the rover will actually figure out exactly how they want to drive in the environment that we're in.
Now, Kobie mentioned that, I got a chance to drive the test rover out in the Mars yard. And what amazed me when I did that was we drove over a rock, and you picture Mars. And to me, I had always pictured it as this silent landscape. And we went over a rock, and there's just this horrible metal on rock grating sound. And it was just horrible. And it just clicked. It's like, wait a minute, this thing on Mars is going to be loud. And so there's actually a microphone on this mission, right?
Yes, SuperCam. There's a SuperCam microphone.
And why? Just to hear the tires grating against the rocks?
Yeah, why not? Well, actually, so there definitely is. So we actually have two microphones. One is coming as a part of our EDL package. So it'll be, it's basically to finally hear, what EDL sounds like, or entry, descent, and landing. And so we'll be able to hear the interactions of the flight vehicle as it's plummeting down the atmosphere, and just listen to the sound so that engineers on the ground can refine models for future entries. But, being an instrument person, the one that's even cooler is the SuperCam microphone that's mounted right below the SuperCam instrument, which is kind of like the eye of the rover when you look at it. And what's interesting there is that SuperCam has two lasers, because why have one laser when you can have two? And so as it's zapping rocks on Mars, the microphone is actually going to listen to those sounds to see what the interactions are with its spectrometer. But, you can imagine everybody's already thinking about, well, what can I use a microphone on a different planet for, right? And so, some of the things we'll be able to listen to the wheels, we'll be listening to the wind, and all kinds of different things.
That is awesome. Now, this next question, I'm going to start a fight. And I know that I'm going to start a fight.
Star Wars or Star Trek? That one?
Star Wars or Star Trek. So in the comments, go ahead and go down. And I'm not even going to ask our guests yet, because I know it is a really, really hard question. So let us know, are you Star Wars or Star Trek, down in the comments section. But Matt, we did have a question about science fiction versus reality. Can we grow potatoes on Mars? And then I'd like to follow that up with a little bit about how important has science fiction been in spurring along the exploration of Mars?
Yeah, that's a great question. I think, science fiction and Mars exploration, and even before Mars exploration, the telescopic observation of Mars, have always kind of fed off of each other. Science fiction helps us to imagine what it might be like to be on Mars, and sometimes, helps us to kind of go a little further than our facts and our theories let us go in imagining those things. Even prior to The Martian, you could think about something like, Edgar Rice Burroughs' A Princess of Mars, where he was drawing mainly from Percival Lowell and other astronomers who said that there were canals on Mars and possibly even intelligent beings on Mars with a civilization and a canal structure that helps them to stay alive. So if you read that sci-fi novel or set of novels, you see Percival Lowell's Mars at work. And I think when you watch a movie like The Martian, you see the Mars that Spirit and Opportunity have shown us primarily, and Curiosity as well. So, there's definitely a relationship there. And can you grow potatoes on Mars? I think, if there's one thing that this exploration of Mars has shown us, is that different parts of Mars are different. So maybe it depends on where you are on Mars and whether or not that soil has, is inhospitable to life, or whether it's possibly life friendly. I think it also depends on what you bring with you. If you're able to alter that soil in ways that would make it, good for growing potatoes. But I'm a historian. I can't tell you for sure whether or not you can grow potatoes on Mars. But one thing I do know is that the soil there is different from the soil on Earth. You talk about Martian dust, and what we're talking about is of the consistency of like the flour in your kitchen. It's not like the dust that we know here on Earth. So, getting it to do the things we expect soil and dirt to do on Earth would possibly be a big challenge.
All right, we've got a bunch of questions coming in wanting to know about how far can the rover go and how fast does it go?
Kobie, want to take it?
No, you
You're a mobility guy.
Oh yeah. So this rover, very similar to the last rover, and we don't normally talk in absolutes of how far it can go. We talk in terms of what the requirements for the vehicle are, and because Perseverance, Percy, Vera, I like both of them. I like Vera, actually. It's my aunt's name.
It's growing on me.
Yeah, it's really growing on me. Yeah, but because it is a almost replica, right? It was built off of and grew from, right, Curiosity. Curiosity's requirements were that the rover drives for 20 kilometers. And we add 10% for various sundry things, so 22 kilometers. So we can easily say, with good backing, that the vehicle can drive for about 22 kilometers. Now, Curiosity has done more than that, and will continue to drive. If you paid any attention to what happened early on in Curiosity's life, there was an issue with the wheels in the particular location that we landed, in that area that they called Hummocky Plains. And the rocks were really sharp, and they poked holes in the wheels. Now, we've fixed that, which made the wheels heavier, which made the rover a little heavier, which made some changes that we had to do mechanically. But we believe that the driving will still be very similar. In fact, the actuators in the wheel are the same actuators. So it's not like we did a lot different in that particular world. So driving distance for the rover would be, the minimum is going to be around 20 kilometers, and the maximum could be tens of miles. There's really, the wear products inside are the same things in the wheel bearings in your car. And so if you get dirt and grime in there, they'll eat themselves up, and at some point in time they'll seize. But in general, we should be able to drive for quite a ways.
Awesome.
And you've made improvements. Oh, sorry.
No, go ahead.
I was going to say, you've made improvements to the wheels on this rover versus the wheels that were on Curiosity. And you also have that incredibly versatile, what's it called? The rocker bogie style of suspension there for the wheels.
Yeah, it's great. I mean, the rocker bogie developed by the guy who actually hired me at JPL. His name is Don Bickler, and with help from a master's student at MIT at the time, was Howard Eisen. Both still, one is at JPL, one's retired. And that passive rocker bogie system is capable of driving over an obstacle that's 1.5 wheel diameters, which is better than any vehicle on Earth. right? The Humvee, the best Humvee cannot do that. The Rover can. And it's impressive to see it drive over a rock that is 1.5 meters in diameter. And it just goes over it like it wasn't there, just whee, and it just off it goes. It's really amazing. Now, we'll never do that. We freak out. We'll never do that on the surface. We'll drive around that rock, but the vehicle could do it if we needed to.
All right. Well, we have started a fight in the comments right now. Star Trek is winning. So Star Wars folks, you better step up. And if you look in the background of what I've got here, I have a little ode to Star Wars up here, and over here I've got a little Star Trek shout out. And I'm impressed by this, Spaceballs also has a vote. So
that's nice.
That's pretty awesome. So a question has come in, and you guys have kind of mentioned this, but I want Christina and Kobie, I want you to talk about this, and then Matt, I'd like you to follow it up with what you can do at a museum. Somebody asked about improvements, and how much do you look at the previous rovers and the previous missions, maybe not even missions to Mars, to improve what you're working on? Christina or Kobie?
Yeah, I'll take a first stab at it. So at least from what I saw being on the payload team, there's been improvements in the science instruments overall, right? And a lot of that is guided by what the objectives of the mission are. So as the missions evolve and we go from just looking for water to looking for signs of ancient life, the instruments also need upgrades and different types of capability. And I don't know if you guys can hear my cat. He thinks it's lunchtime already. Anyways, so the instruments, right? We went from having, maybe just a wind sensor, and now we have a full weather suite that can, measure dust in the atmosphere and even take humidity, pressure measurements at a finer scale than before. And then we also have instruments that are these beasts of autonomous spectrometers that are on the robotic arm, right? I mean, Pixel, just to give a shout out, that instrument, we've never had anything like it. It's mounted on a hexapod, so it actuates itself and it can do fine scale motion, 25 millimeters. So like this close from the surface of Mars, right? That is insane. And so you talk about upgrades, you talk about different capability. We learn from the engineering that has come before us and the science that has come before us. So, in terms of like science and instrument upgrades, I'm really looking forward to seeing what we learn about Mars just with this new capability that we have.
And from Matt,
go ahead, Kobie.
Yeah, go ahead. Oh, no. I was going to say from the larger scale, the high level scale, and we can be criticized for this. So I'll take the criticism too, is that we tend to always, engineers are terrible. We're horrible human beings because we always find the flaws in everything, right? And so if you give an engineer infinite time, they will use it to make the perfect thing, right? We call it polishing the cannonball, but we like to do it. And so every time we build the vehicle, we understand where the warts are. And, because Mars comes around every couple of years, we have to finish. We don't want to finish. We have to finish. It's different. And so for us, we sit there and we go, well, we would have fixed this had we had more time. We would have changed this had we had more time. And so doing the next vehicle, although you want it to be the same, we go, we could fix that little thing. And we could change this little thing. And so we end up doing some of that. And we have to manage ourselves, right? So that we don't do too much, right? You don't want to start a whole new development. And so there's a lot of things on Perseverance that are just upgraded a little bit. Like, we talked about the big one with the wheels, but there's a lot of other little things that were changed because we didn't like the way something, and it's not always aesthetics. It's really about the engineering and how it's working. And so thermal control, some of the things that people don't really see that happens in the background. The rover needs to be kept warm on the surface because Mars is cold. How did we do that on Curiosity? How did it work out? Could we be more efficient so that we don't have to use so much energy for heat? Yes, we could. We found out ways that we did that because we could actually look at the distribution of heat and how it was flowing on the surface, knowing the outside environment. And so like we were just talking about the weather station, knowing the outside environment actually helps us manage that so that we can use more energy for science. So all of those little tweaks are actually a benefit to doing the mission on the surface.
And Matt, when you see artifacts in a museum, how can we learn from those, and can we see those improvements from one thing to the next?
Yeah, some of those improvements are very noticeable when you look at the 3 rovers that we have on display, or will have on display when our Exploring the Planets gallery reopens in a couple of years. So, you can look at at Sojourner, we have the flight spare of Sojourner, the Marie Curie rover. And you can compare that to the Mars exploration rovers, Spirit and Opportunity, and you can see that some substantial improvements have been made. I mean, the Sojourner rover is about the size of a microwave, and you compare that then to the golf cart sized Mars exploration rover, and you can tell that this thing is built to do more. For example, as Kobie already noted, the camera, the pan cam that was mounted on the mast of the Mars exploration rovers is about the height of a human set of eyes, which is not at all the case for Sojourner, which is very close to the ground, like a remote control car, right? And if you look at the Sojourner rover, you also see that it only had one spectrometer mounted to it. I won't tell you what kind of spectrometer it was because most people won't care. The Mars exploration rovers, you have a set of 3 different spectrometers on that, and an instrumented arm that could, abrade material off of the surface of the rock, get beyond the patina of the rock to see what was actually, in the rock a little bit, just, a small amount to be scraped off, but that was still a significant step forward. So you can see that instrumented arm, and then if you look at that instrumented arm and compare it to Curiosity, which we have a full-scale model of in the museum, you can see that this thing is carrying just a much bigger toolkit. And you can see that. You can see the size has gone up. It's now the size of a small car. People say it looks like the size of a Mini Cooper. So, going from microwave to golf cart to Mini Cooper, obviously that comes with a lot of new equipment and new capabilities. But you also see some of the things that stay the same, right? You see, at least moving from Sojourner to the Mars exploration rovers, you see the solar panels continue on. Although, as Kobie could probably tell you better than I can, there were some substantial improvements to solar panels in the years between Sojourner and Spirit and Opportunity. They were able to capture more energy from sunlight than Sojourner was able to. So, you're able to do more with more power. And then you also see one thing that stays constant between all 3 of these rover designs, which is that rocker bogie suspension design for the wheels, which turned out to be just incredibly versatile on a surface where you don't know what to expect from day to day. And you want to be capable of going over all kinds of terrain. Now, the wheels themselves, as we talked about, have improved because NASA and JPL have found, those problems. I wasn't a part of it. I shouldn't say we. I didn't do anything.
It's all we.
Yes, it's all we. It all belongs to all of us. And those wheel designs just continue to improve. And one thing that people love to see at the museum, once you point it out to them, is the way that JPL put their signature on that wheel design for Curiosity. But maybe Kobie or Christina wants to tell us what that is.
Yeah, I'll tell that story.
That's on you, Kobie. I want to hear the story. Whose idea was that?
But I will. What's funny is that the wheels for the first thing I did as a student, and I told you I worked on Pathfinder, was to actually help build those wheels. And the wheel design and the methodology and what we were trying to do has changed as well. And so if you look at the wheels, you'll see what that mission thought before we landed on the surface we were going to have to do. So Pathfinder with Sojourner, and if you see Marie Curie at the museum, it's amazing. Those wheels were actually designed to crawl over rocks, like to literally grab the rocks and go into it. So it looks like a meat grater, right? Once you get to Spirit and Opportunity, right, the design had changed because we found that Mars didn't have a lot of rocks that we had to climb over, but it had a lot of light, fluffy dust on the surface. And so we went from something that looked like a meat grater to a paddle wheel, right? From an old, and that was really the inspiration behind that wheel. Mm-hmm. And on that wheel, we had a thing that held it down to the lander, and it disturbed the soil differently. And the engineers and the scientists found that very valuable, which is to disturb the soil when we were driving. And that became an optical distance measurement device, right? And so optical odometry. So we could actually turn around and look at the times we disturbed the soil and say how far we went. And we could use the internal measurement unit, i.e. the accelerometer in your cell phone, the same thing that's in your phone. You see, you can't see. Anyway, but the same thing that's in there to tell distance. And we could actually, between those two, we could actually see how much the vehicle slipped. So for Curiosity, the engineer that was working on that, his name's Sean, he had this brilliant idea to actually put the letters JPL in the wheels. He did that, and we made wheels, and we got told we couldn't do that. Okay, so fine. He had another brilliant idea, which was to use this old technology that nobody remembers, which is called, Morse code. And so in Morse code, we put JPL on the wheels. And because when people looked at it, they didn't know what that was. They were like, oh yeah, this is great. Go ahead, fly those. And we did. And so now on the surface of Mars, as Curiosity is driving around, it stamps JPL on the surface. And it's fun to have it pointed out. It actually is the strongest part of the wheel. So as the wheel has deteriorated and broken, you can still see that function as the wheel has really fallen apart. Some of those images are great. You should look those up if you can. But so that was actually an engineering thing that became something fun to do. And the other thing that, as Matt was pointing out, if you go to a museum and you look at sort of the history of rovers or even the history of vehicles in space, you'll see some of the technology and developments that have changed the way we do certain things. Like if you go from a solid state recorder on tape to what we have now in technology, or you look at how the wire and cabling was done, or you look at the materials that were used, right? We've gone from having mostly metals, titanium, aluminum, to a lot more composites as you watch the vehicles change. And then for the rover specifically, if you get to see all three of them close, now this is a very unique thing, you'll learn about the differentials, which actually balances the difference between the rock or bogie. For Sojourner, or for Mars Pathfinder, it actually went through the middle of the vehicle. It was called the Jeff tube. For Spirit and Opportunity, we almost did the same thing in going through the center of the vehicle, right? And then for Curiosity and Perseverance, the differential goes up and over the top on a big swing arm. And so you can look at that. And what that forces is a change of geometry. So the pivot point between the wheels is changed, and it actually changes functionally the angle of attack of the vehicle. And if you wanted to actually go back and calculate it, you could figure out which one climbs better. I will tell you that the first one climbs better than all the rest of them.
That's absolutely amazing. Well, thank you all for joining us today. Unfortunately, we're out of time. We could talk all afternoon and it would be great. I do want to put my plug in for Galaxy Quest, if that hasn't been mentioned down in the comments yet. But we want to remind everybody that next week we will be talking about the Chandra X-ray telescope, and we will have astronaut Eileen Collins joining us. And right now, this was the kickoff event for the virtual Mars Day that the National Air and Space Museum is putting on. We have videos we're putting out. We have activities that you can participate in, all kinds of really cool stuff, including Mars geography. So be sure to head over to the website and check that out. Also, that's where the video interview that Jaden Jefferson did with Alex Mathers will be posted. And then part of that is launch a conversation. We want you and your family to have a conversation about the launches that are coming up and that have just happened with SpaceX, and what's going on in society right now and how that compares to previous launches and what was going on at those times. So we hope that you have an opportunity to launch that conversation with your family. And Kobie, Christina, and Matt, thank you so much for joining us today.
Thanks for having us.
Thanks for watching.
Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA. Go SpaceX.
The National Air and Space Museum is launching a conversation.
We want you to be a part of it.
The history of exploration can't be viewed without looking at social, political, and historical events that were happening at the same time.
These are all part of our story.
These are all part of our story.
Part of your story.
We have created resources for you to launch a conversation.
With your kids.
With your parents. With your family.
To look at the past.
To learn about today. Join us.
Join us.
Join us
to launch a conversation.